Good morning. On this lecture onwards, we will discuss about the categories of stars. By spectroscopic studies, it has been found that there is a basic link between the luminosities and temperature of the stars. As you know, the luminosity refers to the actual brightness of the star, which is called the absolute magnitude. So we can say that absolute magnitude of a star has a direct relationship with the temperature. Henry Russell, who is an astronomer from US, and Hertz Sprang of Denmark, Henry Russell and Hertz Sprang of Denmark made a plot of absolute magnitude versus temperature, which is called the HR diagram. The absolute magnitude is taken along the y-axis and the temperature is taken along the z-axis, which is called the HR diagram. Depending on the position of a star in the HR diagram, we can classify the stars into three categories: the main sequence stars, giants, and dwarfs. Here you can see the HR diagram. On the y-axis you can see the luminosity, or which is otherwise sometimes we will represent the absolute magnitude, and on the x-axis we are having the temperature. Every dot on this diagram represents a star whose temperature is read on the horizontal axis or the x-axis, and whose luminosity or the absolute magnitude is read on the vertical axis. In this plot, it is found that almost 90% of the stars lie along a narrow and long band which runs diagonally from the top left corner, which consisting of hot very luminous stars, to lower right corner below, which contains the cool and faint stars. That means if you consider this x-axis and y-axis of this HR diagram, you can see that on the x-axis or the horizontal axis, the temperature is decreasing as you go from the origin to this right side. So as you move in this direction, you can see that temperature is decreasing, and when you go in the vertical axis from bottom to top, you can see that the luminosity of the star is increasing, or the brightness of the star is increasing. So at top of this part it will be bright stars, or the luminosity is high, and bottom we will have and bottom regions we will have less luminous stars. But if you consider the left extreme of the horizontal axis where the temperature is very high, so these portions we will have high temperature, and if you consider the right extreme of this diagram or this graph, you can have the low temperatures. So when a star is at this position, this is actually the position of left top corner. The left means it is high temperature, top means high luminosity. So this part we will have hot bright stars, and if you consider this region is the left bottom region. So in the left part we will have stars with high temperature, and here also the luminosity is less, or we can have hot dim stars in this region, left bottom corner. If you consider the right bottom corner, then right means the temperature is low, and bottom means the luminosity is low. So here we can have low temperature, less luminous stars, or cool and dim stars. And if you consider the right top corner, where we can have low temperature and high luminous. So low temperature means cool stars, and high luminous means bright stars. So this region we can have a cool and bright stars. So what in the HR diagram we can see is that this is called the HR diagram, or Henry Russell Hertzsprung HR diagram, which is a plot of temperature versus absolute magnitude or luminosity of the stars. Each dot in this diagram represents a star. Now you can see that most of the 90% of the stars lies along a narrow band which runs from the left top corner, which is the hot bright stars, from lower right corner below, which contains the cool faint stars. This main band of stars is called main sequence stars. So this is called main sequence star. If you consider the absolute magnitude of the main sequence stars, you can see that it will vary from -7 or -8 to +15. So in the main sequence star you can have stars runs over diagonally from the hot bright stars to cool faint stars. So here the absolute magnitude will be least, so it will be -7 or 8, and here the absolute magnitude will be very high, so it is of the order of +15. And if you consider the temperature, you can see that the temperature is actually changes from 3000 Kelvin to more than 30,000 Kelvins. Examples which lies in this category of star are our sun is a main sequence star, the Sirius is a main sequence star, the 61 Cygni is a main sequence star, Barnard's star is a main sequence star. So these are the examples for main sequence stars. Now if you consider the other rest of the 10% of the star which falls into upper right region, that is this region, upper right region, where we can have cool and bright stars, or in the left corner region where we can have hot, less luminous or low luminous or dim stars. So the cool, here on the right top corner we can have a cool and bright stars which lies on the right region of the HR diagram are called giants and supergiants. The giant stars are big and bright, their surface temperature is low, and they are usually red in color. So giants are the cool and bright stars which lies on the top right corner of the chart diagram. The absolute magnitude of these stars varies from -1 to +1, and for supergiants it varies from -3 to -8. So this is the bright stars. Surface temperature is low, so that's why they appear as red in color. The example for a giant star is an Antaeus. So Antaeus is a red giant star. Now you can see the rest of the stars which lies on the left bottom corner of the chart diagram. They are hot, less luminous stars. They are called dwarfs. Their absolute magnitude varies from +10 to +15. Their extremely high density are approximately 10⁶ times the solar value. Example for a dwarf star is a Van Manen star, is a white dwarf star. Now if you consider the size of the stars, the red giant stars are the biggest stars and white dwarf stars are the smallest stars of this category. So that's all about the different categories of stars. Based on the position of the stars in the chart diagram, that is, they depending on the brightness or absolute magnitude or the luminosity and their temperature, the stars can be categorized into three: the main sequence stars, the giants and dwarfs. The main sequence stars are the living stars, or they are having the nuclear fusion as the major source of their energy. But giants and supergiants, and also for dwarfs, their fuel is almost finished or they are in the dying stages. That's why they are not showing any relationship with the temperature and their luminosity. But if you consider the main sequence stars, if they are hot enough, then they will have a high luminosity, and if they are less hot or the temperature is low, then they will have less luminosity for the main sequence stars. So that's all about the categories of stars. Then we have to discuss about the star formation and the evolution of the star or the life cycle of a star. That we will discuss in the next video. Thank you.